Good morning, guys. Happy Monday. This is a great Monday. This is our last week of new material that we will be learning. So let's start this week out strong. Today we are going to be learning about Goal 12, finding the measures of angles formed by lines that intersect outside of a circle. So there are three different cases that we can have for lines intersecting outside of a circle. Here's the first case. The first case we have are two secant lines intersecting outside of a circle. So remember, a secant line is a line that intersects a circle at 2 points. So for example, this figure shows two secant lines and they intersect at point P outside of the circle. So if we want to find the measure of angle P, so the measure of this angle here, this is what we do. The measure of the angle formed is half the difference in the measure of the intercepted arcs. So for example, to find the measure of angle P, we would take the measure of arc BE, which is this arc here, minus, remember, difference means subtraction, the measure of arc AD, that's this smaller arc over here closer to the angle, and then divide it all by 2. Make sure that you always take the larger arc minus the smaller arc for this. The next case is a tangent and a secant. So remember, a tangent line would be something like this, ray QG. It intersects a circle at only 1 point, and then it's intersecting with this secant line at point Q, and point Q is outside the circle. So if you wanted to find the measure of angle Q, it's the same thing. You take half the difference in the measures of the intercepted arcs. And again, you have to remember to always take the larger arc minus the smaller arc. So the formula for this one, if we wanted to find angle Q, we would take this larger arc, arc GKJ, minus the measure of arc HG, that's this smaller arc over here, and then we will divide by 2. So it's basically the same formula. You take the larger arc minus the smaller arc divided by 2. There's one more case that we might run into. You might have two tangents that intersect outside of a circle. So notice both of these lines only touch the circle at 1 point, point M and point N. And they intersect at point R, and point R is outside of the circle. It's the same case again. You take half the difference in the measures of the intercepted arcs. And again, I have this little pink star here because you need to make sure you take the difference of the larger arc minus the smaller arc. So, for example, to find the measure of angle R, we'll take the larger arc PTN. Sorry, I meant MTN. I think I just said P. I don't know where that came from. And then minus arc NM, the measure of arc NM is the smaller arc, and then divide by 2 to find the measure of angle R. Let's try this out in an actual problem. Example 3, intersections outside of a circle, find each measure. This one we want to find the measure of angle L. So that's this angle here. Let me do a different color. I'll use green. So this angle here is angle L. Notice we have two tangent lines intersecting outside of a circle. So we'll do the measure of the larger arc, which is this arc. So we need to take the measure of arc HJK minus the measure of the smaller arc, which is the blue arc, the measure of arc HK, and divide by 2. So we know that we have the measure of arc HK is 102. That one's labeled in our photo. However, we need to find the measure of the red arc. Remember though, the measure of the full circle is 360 degrees. So if we take 360 degrees minus 102 degrees, that should give us the measure of the red arc. So when we do that, we get 360 minus 102 gives us 258. So we know 258 is the measure of the red arc. So now we can plug that into our formula and then solve. Make sure you always do the subtraction first before division. Remember, there's technically a parentheses around the numerator. So we're taking 258 minus 102 first. That gives us 156. And then we divide by 2. So the measure of angle L is equal to 78. Let's do another example together. This one says, find the measure of arc CD. To find the measure of arc CD, we know that the measure of angle A is going to be equal to the measure of arc CD minus the measure of the smaller arc that it cuts off. So let's write this equation out. The measure of angle A equals the measure of arc CD minus the measure of arc BC divided by 2. Now we'll fill in the pieces that we do know. We know the measure of angle A is 56. We do not know the measure of arc CD. That's what we were trying to find. So we'll leave that as just measure of arc CD. Minus, we know the measure of arc BC is 95. And it's all divided by 2. So once we've substituted in what we do know, we see that there's only one variable remaining. We need to solve or get measure of arc CD by itself. The first step to getting that by itself is, remember there's technically a parentheses around this, so we need to get rid of the divided by 2 first. We'll do that by multiplying by 2 on both sides. So over here it cancels on the right side, but on the left side we need to take 2 times 56. That gives us 112. So we have 112 equals the measure of arc CD minus 95. Now to get the measure of arc CD by itself, we just need to add 95 on both sides. So 112 plus 95, that gives us 207, is equal to the measure of arc CD. So that would be your final answer. Go ahead and try the practice problems on the top of the next page. Pause the video and see if you can do them on your own first. All right, here are the answers to those 2 practice problems. Here's your homework for tonight. You have 2 problems on page I don't know why I can't read these numbers today. Page 746, numbers 18 and 22. And then you are doing question number 36 in the book as your reflection question. Have a great day. Bye, guys.